Well, I'm back again, and I'll just keep you up to date with what I've done. Um, you can see I put the surround around to hide the gap between the table and the track bed. I've also airbrushed all the rails, both sides, all the way around, and I've greyed off the tyres to give it a little bit of realistic. It's probably a little bit bright, but it will just darken down when you wisp over it with a black. One of the other things that I've done is I've connected it to a computer, which has gotten asleep, which was a bit tricky. Because there was a lot of information saying that you couldn't put it on a 64-bit computer, which is actually not totally correct, because it'll the applications are 32-bit. On a 64-bit processor and operating system, it'll put it in a program file specifically for 32-bit applications. You will need to download a couple. It's actually up here. There's JMRI Panel Pro and Decoder Pro. You will also have to download a 32-bit Java to go with it, because it requires a Java to operate. One of the tricky things is the USB to a serial port adapter. I've found that my adapter wouldn't bed down, so I had to remove these little screws from the panel just so I can get it to insert it properly. So it's quite handy, and I'll open a few applications up. Right, so this is basically the trains, the locomotives that you log in, which you'll have to put on your programming track. When you program them, they will jerk backwards and forwards, unlike if you were doing it for the command station itself. But don't worry about that. That is only the software picking up your locomotive. Right, the next one here that I've done is I've also drawn in Panel Pro the layout as it is represented. It's not entirely accurate, but it's a very good representation of it. And then if we go to another one, we've got here, which is all my turnouts. These are all the turnouts that I've got. I've got up to 16. Well, I've actually got more, but they're actually there's 15, because some are crossovers. A lot of them are crossovers actually, so they take a pair. So we'll minimise that. Now I've got a loco on it. This is quite handy because you can control the switches from here, from this map or drawing, and I've just got a where are we? I've got a loco on, which is there at the moment, and I'll just raise the speed a bit, and you'll see what I mean. Okay, now we'll just take it up to there. Now you can switch the motors from here. You can hear them switching over, and it changes the diagram as well, which is a good representation of what's going on. So you can actually keep it going. So now we can drop it into reverse, and you'll see that it will follow it'll go up through the switches, or the crossovers in this case. Okay, it's actually quite handy because it's a one mouse right side to turn them one way, and so it's left mouse button to switch them one way, and then right mouse button to switch them the opposite way. And once again, we'll bring up my throttle and I'll put it back where it was originally came. And I've got to find this damn curved mouse. So this is an application that you'll need if you want to go fully computerized. This isn't set up for it because you'll need to put block detectors in. I haven't put block detectors in at the moment for this. You can still use your cab, your normal cab, as well. I'm just going to switch it on. So I can still control the train through the normal cab, and all the switches again through all the cabs as well. So you don't actually lose any functionality. If you're running a 32-bit, 34-bit operating system, you might get a driver for your USB to serial port adapter, but you might find that that's actually a 32-bit software, which means in my case I had to download, explore the internet and download a 64-bit driver for it, which is okay. It works fine. I'm quite happy with it. One of the questions that I got, I'll just turn it off because I might have to actually show you a few things. One of the questions I got was, how did I get here, you know, and I'm not really certain on what they particularly wanted to know. So you have to, what I did is I had a set of key criteria of which I wanted to do. One of them was to run the big boy. It also had to be a certain size because it's quite a large room that it's in. And then I sat down for a few days and drew a diagram of pretty much exactly what I wanted. It's not entirely. I would have liked to either have a Y in there, a reversing loop, or a turntable, but I was unable to do that. But I also wanted to have at least one helix. In this case I got two. So I sat down and I drew it out. Now I then calculated the curves, right? And there's a list of all my curves, both in millimeters and in inches. And I've also laid them out on top here so that you can see where they are. They're obviously going from largest to smallest, with the helix only being about 10 inches. I also then made up, you see in the profile there, of a little track section of what I wanted and how I was going to achieve it. This is just a 7mm ply. I think that works out to be 930 seconds. There's 3mm medium density foam rubber, which is the similar foam rubber the wetsuits are made out of, except for that it hasn't got the fabric on it. And then there was 4mm of cork bedding, and then of course the track work. I also used this, you could probably see that it's greyed out as well. I also used this as a bit of a test specimen for my colour scheme for the rails and the sleepers, although I have played extra with this and darkened it right off, you know, it went a bit too dark. So of course once you've done that, you've worked out your clearances and everything like that, and your gradients, and I've worked out my gradients. I've got on my main lines, which are these two loops, I've got a gradient of 1.5% and a gradient of 2%, right? And the helix has got a gradient of 3.4%, which gives me a rise of 34mm. Okay, and then of course this is just the track bed, the table itself. And you can see I sat down and I worked it all out. It's going to have a glass top on it. And one of the other criterias was that it can't be any more than 500 millimeters overall. A lot of it's just bought off the shelf sort of stuff. It's I think it's 1.5 inch by 3/4 inch, and they're just laminated together as you go up. And these blocks, which are, there's 6 of them, are about 3 millimeters or 1/8 of an inch, slightly higher than the sum of these 3. And the idea of that was to ensure that the hinged bed actually rested on these blocks and not on here, and that way I could guarantee that it was all sitting flat. So then I worked out what I wanted to do with regards to switch motors. Now I wanted to go turtle. I originally thought about doing Pico solenoid switch motors, but I thought, well, no, I wanted a little bit more true action, so I went for the Smales. Now the Smale is, in all intensive purposes, a tortoise, but the only difference being is that it has a decoder actually inbuilt to it, and I just thought it was easier to buy one product than it was to actually buy 2 products. They can be quite expensive, you know, but you can buy, I bought value packs, so I bought 18 of them. This is a spare. I've got another 2 spares as well. And the way I wired them up, you can see these 3 wires here. I think they're 21 gauge, right? And these 3 wires is obviously is so you can attach a manual switch or a press button for it. The clear wire here, which is probably a little bit short, going to pins 1 and 8 are 18 gauge, and they're actually your power to the switch motor itself. Okay, and these other wires here are just your active return out, switch out again, and then return, and then inactive. You don't necessarily need them all. If you were to have a crossover, that would go to one frog, and that would go to the other frog of the crossover. I put them all on terminal blocks. Ignore this wire here. This wire is just so I can test it with the 9-volt battery by just connecting those, you know, bridging those out. I put them all on terminal blocks. There's 11 wires, just terminal blocks 12. I couldn't be bothered cutting them down, so I just left it at 12. There actually are a handy feature. You can change the CV values on them, so that you can have a single button and just press the one button and press it the second time, and it will just alternate between the 2 switch positions. And then when I installed these, where's my paperwork? When I installed these, I put them. I put them. I used remote mounts to mount most of them, except for 2 of them, where I put them up as a normal switch motor for cyclotron would do. So I use these remote tortoise mounts in most of them. And these can actually drive too. You'd have to buy another one that is your remote actuator, which is basically the similar sort of thing without the actual remote mount. And that way you can actually drive a crossover using the one turtle, or in this case the one Smale. If you were to read the instructions, if we look up here, the wire, which is, where is he? He's just here. Is he? Where is he? I think he's there. I need my reading glasses. But the wire there, they instruct you to put them in the middle. And it's the same with if you were to normally mount them, you would put them in the middle. I'm not a fan of that idea. I didn't like it. I thought it gave it that toy appearance. So I moved them out to the side of all of them, actually, even the normally mounted ones. And it gave a much better appearance. The geometry is basically the same. You just center your switches and measure it off, and then work your way through that. From that, I have the ability. I have access to a lathe and a mill out in my workshop, so I just milled a block of brass. Every time I drilled the hole, it was always in the right spot, and it was always square vertically, and both directions vertically. Now, one of the other tricky things that I encountered was trying to work out how to get a DCC friendly switch. Now, this is a Y, and I've wired it up for DCC. Now, this isn't going to be used, so I really just did it so I can explain how you do it. Right, now, these are your feed wires, obviously, and the way you do it is ignoring these wires here. With your feed wires, you just bridge these two rails out. I've offset them slightly so I can just keep a bit of structural integrity with all the switches, you know, keeping the fact that, you know, all these sleepers are actually joined. And once I've soldered those on, okay, I then cut across. I don't know if you can see that, there's a very fine gap there. I used a very fine razor saw, and then I cut across there, and then ensured that they were all isolated from each other. Okay. I then put this on the bed, the track bed, with just these two wires out, and then I put with a whiteout pen, right, because it's got a very deep nozzle, so you can actually get right in between here. I put a dot on either side, and then where I was going to put my frog wire, which is always in the same spot, I then put a dot on either side, and then where I was going to put my point rails, feed wires, I switched one side, put a dot, moved it across, put another dot, and then with a slot drill, I slotted there, drilled there, drilled there, drilled there. Of course, this is going to be in between the two dots, not on each dot, whereas this is going to be also in between each dot, and this you'd slot just between the dots. So once I've done that, I would take it off, slot it, and I would also put these feed wires on, and these two are 22 gauge. This is 18 gauge. This is 18 gauge, and this is 18 gauge. Okay, and then you just drop it in, make sure it's all right, make sure that these wires aren't binding so you can get free movement. They don't hinder the switch motor at all, pulling it across, because they're quite flexible, and at the end their location is that they don't move. We're only talking fractions of an inch. You know, so they don't move very far. So you then bend these down. They're a bit stiff because the solder's run down under the insulation, and then you just tuck them in like that, right? And then these wires get connected to their, one gets connected and the other one to the other one, and that way you've got power permanently to that, but never that, because it's dependent on where this internal switch is in your smile. To insulate it, you then put these insulator gaps, Right, that's all you really need to feed, because this obviously is going to be another active. All right. However, in my layout, I actually put these insulator frogs on all four, and I kept these ones a typical fisher plate, but these insulated joiners I put on all four rails, and that gave me a guarantee that it wasn't going to short out, or there was never going to be any issues with it. As I said, I've got them laid out at the moment, so if we can quickly have a scan of where you can probably see and wander around, you can probably see where all of you zoom in on them, you can probably see where all the templates fit in. Okay, and you can see where where they all fit in. I've been working on a few other things. The buffers at the ends there, they're going to be changed because they're more British than an American style, and I'm not a fan of them. I do have 6 of 8 of them up there that I've been painting as well. I'm also going to be putting a platform around here, so hence why this one's still a little bit high, because I don't know where to cut it down to. So I'll get onto that. Now with these are actually 3mm or 1/8 of an inch ply. Now they're a bit tricky because of course you can never buy bloody ply or any material from a hardware store that's straight. So it took me a while to get them straight. I had them ripped down to strips, but they were a bit warpy. They were warping a bit, so I tried steaming them with just a steam iron actually, and they reacted quite well. But the problem is they ended up trying to chase my tail with it. You'd steam one side and it would go one way, and then it's a bit excessive, so you would try to steam the other side a little bit to get it back the other way, and it would just go too far. So in the end I gave up, and I adhered a aluminium box section to all of them all the way around, and that guaranteed that they were absolutely straight, and as you can see they worked out quite well. Now one of the other things I'm still working, I've done the mesh. I've put my terrain mesh on, you might be able to see it. I've glued it all down to my dowels, which I pulled out because they weren't glued in before. I pulled them out, cut them to the size, the height I wanted, and then I glued them down. And I glued them down over a period of a week or two, because what happens is that you got to hold it down, but the glue would also get absorbed into the end of the dowel, which I then, before I glued back into the bed. So I over a couple of days I just kept on adding glue until there was enough of it. You can see that it's quite a lot of glue, to make sure that it wasn't going to pop up again. It will get paper mache over the top, which I've got to work on. You can see there's a little bit here that I'm still doing. But one of the other things is there's going to be some structures. Now I've had them on order, and the reason why I've sort of jumped to doing the buffers as well is because I'm getting frustrated with the availability of N-gauge stuff. So the buildings, I'm starting to think that it might be just easier if I scratch build all my structures, and that way I know I'm going to get what I want. Now to get the templates, I'll show you a little trick that you do in, I'll take this small one. I'll show you a little trick that you learn as a boilermaker, because sometimes in the fabrication industry you may have to do large layouts on the floor, And you can't simply use a 2-foot rule or a 600mm rule square, sorry, to produce something that's square, that's 100 feet long. So you actually have to sort of know how to get something square with of reasonable length. So I'll show you a little trick. Now, a little trick is that you have a line, okay, and I'll just put my reading glasses on, which are just here, so I can see what I'm doing. And say that's an end point, and this is how I actually got my templates. Okay, so, and then you've got a mark there, so you then scribe a line, basically 90 degrees, in fact, to make sure it's slightly over 90 degrees. And without changing your compass, you don't need to change your compass whatsoever. I used tremels, which are basically compass points that can be attached to large bar stock. I have a friend that's got a pair, which means that you can draw really large radiuses. Okay, of course, without moving it, you then move to your first point and scribe a line, then to that point and scribe another line. All right. Then with a ruler, or a steel rule, you just join up all those 3 lines. In fact, you don't have to, but you can see that. But you produce this line, you produce this intersect. All right, now, once you've got that point, you then just draw a line between them. Okay. It's a bit out, but never mind. So theoretically, that's now should be 90 degrees. Okay. Now, another way you can check that is what we refer to as the 3-4-5 rule. Okay, so I'm moving it in an inch because I'll just do it normally like most people. You shouldn't, but anyway. So if we go 3 that way, and then if we go 4 that way, okay, this distance here should be, there it is, it should be 5, and you can see it's pretty close, and that's 5 there. It's 5 inches. It's quite handy because you could use it in any dimensions. You can use 3mm, 3mm, 4mm, 5mm, 3 inch, 4 inch, 5 inch. You can use 300mm, 400mm, 500mm. You can use 3 feet, 4 feet, 5 feet. So as long as the units are a multiple of 10, or 100, or 1,000, okay, you'd be okay. But anyway, going back to my template. Okay, so now we've got it 90 degrees, because you will need 90 degrees. These templates are 90 degrees. The only one that's not is the helix, which is 180 degrees. So now we've got that. Okay, now we know, go to this point and we get this. Well, it's a bit out again, but never mind. Okay, and then of course if we put it on this other edge, we get that. And then of course I've scribed all them out on my template, on my board when I was doing the template. Okay, there is a particular reason, because we now know, where is it? There it is. Something's on my bed. Okay, so we know now that that's 30 degrees, that's 60 degrees, and that's 90 degrees. Okay, which is what we got here. We've got 30, 60, well it's got 0, 30, that should be 60, and that's 90. Now I've put a 45 in here. Now the reason why I put a 45, which is easy, your compass still hasn't moved yet. Okay, so now you scribe there, and then you go to this point here, and you scribe there. Okay, now that point is halfway between that point and that point. Okay, and you scribe your line, and we now know that that one's 45 degrees. And of course, if you break it down, you can get, you know, half of that. And keep going, you can get down. So you keep going down, you'll never get to 0, you're just halving one each time. Now, like I said, this one's 90 degrees, okay? So if I needed a 90, you know, which is always what I started off with, the 90, I just traced it out, okay? I traced it out and slowly cut it out and slowly worked it around and marked my centre line, you know, just a little bit at a time. Just marked my centre line, and that way when I put the cork bed down, which I slit down the middle, I had a centre line to follow. Okay, and I also, what I did, and this is why it's important to the 45, also made my splice plates, and I just traced out the centre of it. Okay, you mark off your ends, which will be 60 in this case, and 30 in there, and your 45, and that'll be your centre line. That'll be where the actual split of the joint is. So that's centre line. All right, and then you'll just mark them off. And that's basically a splice plate. That's how I would have made it. In fact, it is how I made a splice plate for this. So it ends up being like that. Okay. And then you can just drill holes. I like I said, I'm a boilermaker by trade. Built a lot of bridges in my time. So I put quite a lot, actually, of screws in there. But I did glue and screw. Okay, ouch. And there you can see my turntables. So that's simplistically how I got the templates to make my curves, and then how I made a splice plate to join it to another. If you wanted to just get you can then have a straight. And you know that this end is, you know, it's a radius. So you just butt it up against the straight and you have a straight and a bit of a curve. And your curve, of course, you just splice it, add another curve, and then you're back onto a straight, if you just want to do a straight out oval. Now, it's important that every piece of track gets a power feed with DCC. And the reason why they say that is you can't guarantee the Fisher plates to carry the voltage or the current that would be made to go through the Fisher plate. Also the fact that, as you see with my switch motor, I put these power feeds in it. Most people, these power feeds on the switch blades themselves. Most people don't. They obviously get joined like that. Most people don't, but it was recommended that you do, because you can't guarantee this hinge is going to be conductive all the time. And if you use a multimeter, which I did, you will get an intermediate feed. So it does. These hinges don't can not give you conductivity, which is not unusual. That pretty much wraps it up. And I don't know if I've got much more to add, but if people are interested in specific things, just let me know. and I'll see if I can answer them for you. I'm more than happy to answer them for you. So, well, that's about it, and I'll sign off for another time. It will take a little bit longer because I'm starting to get into the detail side of things, and I want pretty much as much detail as I can get. I do plan to put signalling in it, on it, which is handy to do because that way people won't be actually driving locomotives into closed points, which is a pain because it shorts out the system. The NCE can handle it. It'll short out, trip out, and after about 3 seconds it'll try again. If the short's still then, it will just keep going out. But you know, you've got to make a quick dash to turn it all off and find it all. So, okay, that's me signing off, and hopefully I can show you a bit more next time. All right, bye bye.